Hi guys and girls, this is Astronomy for Beginners and this is Martin, and today's topic we're going to cover is reflectors. Alright, as we covered before with refractors, also we're going to cover what is a reflector, how it works, what are the advantages and disadvantages of using it, and some form of recommendations that I would suggest having for a particular beginner. What we have here is a typical reflector. Alright, same sort of similar setup as a refractor. You've still got your tube rings, your dovetails, your finite as I mentioned before. Alright, but the only one slight difference with this particular instrument is instead of using lenses like the refractor, it also uses this particular instrument uses mirrors instead. Okay, right. Obviously it's going to be a bit difficult to try and move this instrument around, but I'll try my best to try and show to you what. Okay. Again, he has its it does cover off. Right. What you see here is you can see the main mirror at the back. Alright, you might not be able to see it through the camera, but you see the big main concave mirror. Alright, highly grounded down to a millionth tolerance, and it's plated with like an aluminium coating, highly polished. And then in the middle here, there is the secondary mirror. Okay, how this telescope works, based on mirrors, is all the light gets reflected down this tube. Okay, and it comes into the main mirror at the back, and at that main mirror the light gets reflected back, comes and hits this secondary mirror here, and then that light is then transferred 45 degrees to the focuser here. That's where your eyepiece will be situated. Okay, very simple device. Actually devised by a guy called Isaac Newton. Okay, very famous scientist, you know, and he devised this. Now, obviously, a simple device. The thing is, as this works, you know, similar to like refractors where they bend the light, this reflects. Hence the reason it's called a reflector. Alright, you get different types of reflectors, but you get a Dobsonian, which is this one behind me, and you get a Newtonian. The only difference is a Dobsonian is basically still the same as a Newtonian, but because it's mounted on a Dobson mount, okay, that's the only reason, that's the only difference. But again, they're all the same instruments. Alright, okay. Right. Now, a lot of guys were saying to me is, why get a reflector? Well, there's so many advantages to this optical device, and one of them is, as I mentioned before, with refractors, the reflector exhales in, it doesn't produce any false colour. In other words, this is absolutely free of false colour, no matter what. Okay, so you will not get any of this false colour. The disadvantage of this optical device is you do get a little bit of coma. Basically, the coma is if you look through an eyepiece and you see like an outer field, you look at the stars. Now, some of the stars in the centre appear pinpoint. But if you go and look around the edges of the field of view, as you look through the eyepiece, you see like little comet trails or something like that. Basically, what that is, because the main mirror is curved, all the light reflecting in that certain way, it produces this coma. Now, I'm not here to scare you guys like how, that to put you off. Alright, you can actually eliminate coma by fitting a coma corrector into the focuser tube, and then you attach your eyepiece and all that. You can eliminate it. On longer reflectors with a longer focal length, alright, the coma is less severe. It's when you go to short focus reflectors, particularly this one, this is an f4, that's when the coma gets quite bad. So the shorter the focal length, the more the coma is. But like I say, you can always eliminate it by fitting a coma corrector. Alright, that's one thing you can do with this. The advantages of the reflector is, like I said with the refractor, one, it's the cheapest telescope you can buy, dead cheap, with loads of aperture, and you get more bang for the buck. Basically, a similar size reflector, if you can get a 6-inch to 8-inch reflector, you're talking around about a good 200, maybe 300 pounds for a Dobson mounted one, and that's really cheap. The reason why it's cheap is, like I said before with refractors, you've got to machine both sides to make the elements, the lens elements. With this, it's only the primary mirror that actually needs to be grounded to meet tolerance. It's only one surface, and then it's aluminium ice with a plating, and then the secondary is just a flat aluminium coating. That's it. Hence the reason why they are so cheap. Alright. As a beginner for reflector, you can't go wrong. These reflectors are absolutely brilliant for deep sky objects, alright, because of the huge light covering capacity. You can collect more light than any refractor can, alright. And for visual, you'll see a lot of detail through a lot of galaxies, nebulas and all, and they just pop out like no tomorrow. Also, they could be used for the planets and the moon. However, due to the slight obstruction of the secondary mirror, they tend to be a bit less sharp. Alright, they're not as sharp as compared to a refractor, where you get the rays of crystal clear images. Here, alright, you sacrifice a slight bit of resolution, but the aperture is unbelievable. You can't get a cheap telescope for a staggering amount of, because for something like this, I mean an 8-inch, this is about £400 for an 8-inch. Obviously this is a slightly different Newtonian. This is really designed for photography use, alright, because of the certain focus and all that, and obviously the mirrors are slightly closer in to allow CCD stuff to focus. But really simple device. The only bugbear with reflectors, between if you get a reflector between 6 to 8 inches, you're really pushing it for portability. Alright, 6 and 8 inches is usually the limit portability, and they get heavy as well. So anything past 8 inches, it gets extremely heavy. This guy here behind me, that weighs about 60 kilograms. So as you see, and that's a 12-inch reflector. And as they get bigger, they get heavier. That's the only problem. The other problem is, a lot of guys are deterred away from reflectors because of collimation. Now, collimation is actually not really difficult. To be honest with you, collimation is really easy. It's knowing how to do it. Now, obviously, I'll show you how to do it on a later guide. But believe it or not, all you got to do is usually you can use a Cheshire eyepiece on there or laser collimator, and basically you just the secondary first. Once you've got the red dot or whatever you see for the Cheshire is central to the reticle this is a reticle in the main mirror. Once you get the beam in there, that's it. And then once that, you then look at the sight or obviously the collimation thing, and then you adjust the screws at the back, and then you adjust it to its centre of that. It's so easy, but I will cover that on a later date. Alright, guys, do not be deterred away from collimation. Alright, okay. The throw of collimation, when you take it to a dark side or you move the telescope about, it will the mirrors get misaligned and they move out of position. It's easy. Don't let it put you off. All right. It is important to collimate it, because if you don't collimate it and the mirrors are not quite aligned, what you're going to do is you're going to lose detail on the planets. Your views won't be as sharp, you know, and they might blur as well, so they won't perform as they should. Alright, so that's the reason, you know, you've got to collimate them every time you use the scope, alright, but don't let it put it off. Also, another disadvantage with these reflectors is there's a lot of upkeep as well, particularly for the main mirror and all that. Alright, when the optics gets dusty, alright, these need a special, a special way to clean them. Alright, and time after time it will go dusty, but my best advice is, if you got a reflector, don't touch it. Don't touch the optics on the coatings, even on the flat. If it gets dusty, let it go dusty. Alright, that's the main thing. Alright, it's not going to degrade the view of the performance of the scope and all that. It's really important that you don't touch the main mirror. Alright, if it gets a little dusty, fine. The only time I've ever cleaned my main mirrors on my reflectors is once every 2 to 3 years, providing you put the dust cap, like I said before, when you're not using it, it's fine. You know, you'd be surprised how long, you know, it will get dust in there and it will come in there, but it will stop a lot of dust from entering. Alright, but if you're keen to try and clean the mirror, alright, it's not as simple as just like a refractor. Alright, but I'll cover that and another guide as well, alright, on how to clean a primary mirror. Alright, there's special techniques. Where it does, do not try and strip it. Another thing as well, the coatings as well, they're so delicate. Alright, they've got an aluminium highly polished surface on the top, so the mirror, the coat is on top of that glass. Alright, don't touch it. Never touch any optical devices in this system, because what you do is any fingerprint or something, you're going to scratch the coatings and it will degrade the performance of the telescope and in a bad way. I've heard a lot of rumours, people are a bit deterred away from that, but believe me, I mean, I've had this for a good year and a half, and believe it or not, I haven't got an ounce of dust, providing you keep it covered always, alright, and you can't go wrong. This is absolutely fantastic scope. Don't let all this maintenance things put you off, alright, but when you do need it, and when it stops, you know, if the light's not as great and all that, and there is a bit of dust, quite a lot of dust and stuff like that, I would say general rule is 2 to 3 years. Take the main mirror out and then clean it. Alright? But I'm not going to start doing that just as yet, until it's, you know, on the next guide. Okay? Right. Also, as I mentioned before, being cheap and all that, again, these aren't as robust as your refractors, alright? They can't take a bit of a beating, alright? Especially with the veins and all that. They are a bit delicate, but like you say, for the price and you got the biggest bang for the buck, alright? You cannot get a telescope as fine as this, alright? And a lot of people, you know, don't like reflectors, but to be honest with you, I've had reflectors, and they're probably my most favourite, favourite telescope that you can own, and they are simple, alright, but all the same sort of setup as like a refractor. Ignore that, that's just electrical focuser just on the side here. Alright, most of them are just a creation focuser. Also, this one's got a 10 to 1 focuser here. Alright, but my recommendations for a beginner in particular is, like I said before, keep away from catalogues, alright, and all these retailers. Don't go to a shop that doesn't specialise or don't know much about telescopes, alright. Go to proper telescope shops. They're all scattered around the UK. Highly recommended that you go and look at them, see for yourself. Alright, also a decent sort of size. Now it depends. Now a lot of guys say go for a 6" to 8" reflector and you can't go wrong, which is true, yeah. But to be honest with you, I mean, for the guys who are on a really limited budget, a 5" reflector or 130mm reflector is actually really quite a good scope when you think about it. And I've actually used one. I've seen through one. All right, I'm really surprised. So a good 5" reflector, you can go as small as that. But I will not go, and I won't stress, won't go anything smaller than that. All right, 5", no less. All right, for the guys who are on a limited budget. Now, there is one guy that I know, as a personal friend as well. He's actually got a 130mm reflector, and he has the go-to SynScan out of mount. It's a Skywatcher, 130p it is, and fantastic scope for the price. And I think it's around about a good 270, maybe around about £350 mark. But that is unbelievable scope. And the good thing about that scope is it has it is a go-to telescope. So basically, it will find your objects. So as long as you put in the date and time, location where you're at, and then line up 2 bright stars in the sky, normally, it will find your objects. So you can get a fully go-to telescope with 5" of aperture, and it comes with 2 eyepieces as well. And I believe in the Barlow, I'm not quite sure of Barlow, but unbelievable scope. And believe it or not, he's still got a scope. He's had it for about 4 years now, and he loves it. You know, absolutely loves it. As I said, the aperture is the key with this scope. All right. Now, like I say, don't go anything too big, because when you get big, it gets heavy, it gets bulky, and it's a nightmare. And you can hardly get it in your bloody car as well. So you got to be careful what you buy, because one thing I realised is this scope particularly. Alright, it's 8". It's quite heavy. It weighs around about 8 kilos, in fact 9 kilos, or just about 110 kilos. Quite heavy, but it's quite portable. So again, get something that's reasonable size but portable. Alright, so you can manage it. But if you start getting something that's bigger, you might not use it, or hardly use it, because it's a nightmare. As I said before, as you go for increased aperture, now if you're one of the guys who are very unfortunate and lives in a a town or a city, a reflector is not really the ideal scope for you. Alright, reflectors are really good for if you take it out to a dark site or somewhere that's remote. Because what happens is, because of the extra light gathering capacity, will also increase the light pollution as well on this equipment. However, if you still want reflecting, you live in the city lights, you can still get away with it by fitting a light pollution filter, which you screw onto the eyepiece, and that will help. Bear in mind, when you use a light pollution filter, you're going to lose a few magnitudes with it. Alright, but what I'll do is we'll darken the sky background, eliminate all that pollution, and we'll make the nebulas and the galaxies pop out a little bit more. However, light pollution filters can be a bit expensive. You know, we're talking around about 50, maybe £60 for a cheap one, and £100 or not for a really good one. You know, so it is expensive, but like I say, reflectors, you can't go wrong. Fantastic instrument, without a doubt. Obviously you're going to get collimation issues, you're going to get a bit of maintenance from time to time, but don't let that put you off, alright? But like I said, one thing I've got to mention is on this particularly, a lot of people saying, can you use this reflectors for photography, astrophotography? And the answer is yes, you can. In fact, you can use any reflector as long as you can fit a camera adapter, or with the Skywatcher ones, usually with the eyepiece holder. If you get an eyepiece holder on the 125 adapter, you can actually unscrew the cap on where the thumb screw is, unscrew it, and there'll be like a T-thread on there. On that T-thread, it enables you to connect a DSLR camera. With that DSLR camera, you need to get a T-ring specific for that camera, so that it will screw onto the T-thread and you can fit a camera. Now, another thing is it's more or less on short focus Newtonians. Because it's a short focal length, it means that the secondary mirror moves further in. Now, on this particular one, because it's around about f10 or f4, with a shorter focal length, what you'll probably find is if you don't have the extension tube in that, you'll find that some of the eyepieces don't come to focus at all. So you actually need an extension tube. However, from like f5 and f6 category, you're going to get most eyepieces work anyway, and there's no extension tube needed. But particularly for this model, which is an f4, alright, you usually have to fit an extension tube on there. And when you're using DSLR or CCD, you take the extension tube out, or else that won't focus. So obviously, there's some slight niggles of this scope as well. But yeah, as I mentioned about focal length, alright. Okay, the short focal length is alright, okay for planets, but the resolution is not as great. Now, if you want a reflector for the planets and the moon, and you want the crisp views, then you can get reflectors as long as f8 and f9, but they're a lot longer, alright. But what you do is they have a smaller secondary mirror, and basically with that smaller secondary mirror, there's a lot less obstruction. Alright, and with that obstruction, we'll increase that resolution just that little bit more. Okay, and then that will, when you're using such a device, a longer focal length, alright, you can use it for deep sky, but it might be a slightly bit dimmer compared to a short tube reflector. And also with the added focal length as well, it's not really ideal for DSO, for DSO imaging. Alright, for this. F5 and F4 is usually ideal for if you want to take images of the DSOs or the deep sky objects. Alright, but like I say, a good instrument, if you're looking for a decent telescope with good aperture, cheap price, don't mind the bit of the old maintenance and occasional cleaning from time to time, then to be honest with you, you can't go wrong with reflector. And don't let the people put you off for not buying one, because believe me, they're not that complicated to use. Alright, fantastic instrument, and I would seriously recommend it for a beginner, definitely, without a doubt. And like I say, obviously I'll go to the next two guide, and I'll see you there. So. Obviously, yesterday we had some good responses from the Facebook. Alright, a lot of people asked a lot of questions. Alright, feel free to ask any advice. I'm here to help, and so is Simon. And like I said before, on Facebook, feel free to put all your images that you've taken around, share them along amongst us. Even your instruments or telescopes you own as well, we'd love to see that as well, because then just share, feel free, right? It's all there. I mean, if you've got any other guys, you can add yourself, fine, just put it on there, no problems. Okay, but obviously the next guide will be on Maxitov Cassegrains. Now, obviously I have a Maxitov, but I don't have a Schmidt Cassegrain, unfortunately. But I will deal with it in the same sort of scenario. Okay, so I'll see you then on the next guide. As I said before, see you later.